Right, moving on, and example 3 just starts us looking at identifying what a mapping is and just sort of clarifies it all in our mind. And it starts off looking at this one. Which of these following mappings represent functions? Well, we can see that 9 is being mapped to 3 and to -3, 2 is being mapped, 4 is being mapped to 2 and -2, and 1 to 1 and -1. So we're thinking this is square root, and quite clearly this is not a function. We have a problem here that each of our inputs is actually being mapped to more than one output, so it's just not a function. End of. Part B is a graph. It is a mapping. It maps a x value onto a y value by reading up to the line, looking at the point, and then looking at the value on the line, reading across to y, and we can see immediately each value of x is going to map to one value of y. So yeah, this is fine. This is a function. It's a one-to-one function, and it's written in the form y equals ax plus b or y equals mx plus c, and yes, it's a one-to-one function. Now part C is quite an interesting one in that we have a value for x that maps onto a value for y, and just one, and again, and in fact we can do that sort of anywhere on the graph. Each of the x input values will map to one output value. However, there is an issue here. There is a value for x that we cannot put into our function. We cannot put x equals 0 in. Now if we look at the definitions again of what, or if we look at the definition of exactly what a function is, let's just get rid of this. A function is a special mapping such that every element of the domain is mapped to exactly one element of the range. Every element, and that's quite important. Every element has to be mapped, and in this case one of them isn't. X is 0. So as it stands, this is not a function. Okay? We will talk more about this in the non-too-distant future. But as it stands, this is not a function. I can make it a function fairly easily. If when I'm stating my domain and I say x can be any of the real numbers, but if I just put x does not equal 0, as in what I'm saying here is when you're putting your values into the function, you can put any value you like in except for x is 0. Now it becomes a function, because now all of the values of my domain, all of my input values, map onto one output value. So now that would be a function, but that's not what the question says, so we, as it stands, are unable to say that that is a function. Part D, we have a quadratic curve, y equals x squared minus 1, and when we take this value of x, it maps onto this value of y. Now it does happen that when we take the negative version of that value of x, that gives us the same value for y, but each x value is mapped onto one y value. So yes, it is a function. It's a many-to-one function. Okay. Now that's about it for this first section. What I want you to do is pause the video and have a look at exercise 2b to begin with. You should have maybe had a quick look at 2a as we were going through, or just to sort of check over its very basic mappings. Now have a look at 2b, make sure you can answer the questions, work through them steadily. It shouldn't take you too long, and of course if you've got any problems let me know, but otherwise pause the video and get cracking with that. We are going to look at the next section, and we're now going to talk a little bit more about what I've just not long ago mentioned, this idea of actually changing the domain. Okay, and if we change the domain, that can help us turn what was a mapping and turn it into a function. Okay, so root x, y equals root x. Now we've already stated that there's an issue with this. It's probably just worth noting that by definition, when we say root x, what we really mean is the positive square root. Okay, so that's why this graph looks the way it looks. They haven't included these values down here because by definition, if you use that symbol for the square root, that does mean the positive square root. So for example, if I write root 9, the answer is officially 3. It is not plus or minus 3. Okay, that's just a little aside. But we do still have a problem with y equals root x. It is not a function because any values of x less than 0 don't go anywhere. So I can't put in any of these values of x and get do the function and then get a member of the range out. There is no solutions down here. That's obviously because we can't square root a negative value. But what we can do is this. We can write this function as f of x equals root x, as you can see down here, with domain x can be any of the real numbers, that's this part, and then we can say but x must be greater than or equal to 0. Now that we've specified that our domain is x must be greater than or equal to 0, we're now in a situation where all of our x values, wherever we pick, will map onto a single y value. Okay, and that is what we're after to make it a function. So that's how we do it. We essentially take a mapping and then we can adjust the domain to allow it to become a proper function. So looking at some functions and trying to work out what the ranges are, we're going to do very similar to what we were doing last time. I'm not going to spend a long time on example 4a because these are fairly infrequent, but it says f of x equals 3x minus 2 and the domain is x equals 1, 2, 3 and 4. It mentions here this is discrete. Okay, you might have used that word when you were doing statistics at GCSE, where you talk about discrete data, where there's discrete members of data sets that you use, so colours or shoe sizes, as opposed to continuous data, which is the other type, and actually we're going to see that in a moment as well. But we're talking about a discrete domain, and just these values of x go in, 1, 2, 3 and 4, and the values come out 1, 4, 7 and 10. And the range of f of x is actually 1, 4, 7 and 10. That is discrete as well, and we can see that it's clearly a one-to-one function. Now for part B, we've got g of x equals x squared, g of x just being another function. We can use f of x, g of x, h of x, whatever we want. G of x is x squared, and the domain this time runs from -5 to 5. It is a continuous domain, okay, because we can take any values. It doesn't just have to be positive whole numbers or negative integers or anything like that. We can take decimal place values as well, or surds, real numbers, so anything sort of positive, negative, as long as they lie in that zone, we're fine. So g of x equals x squared. This is what the graph would look like, and we can see quite clearly that one x value maps onto one y value. Each single member of the domain maps onto one member of the range. Now, what about our range? What is the range of this function? Well, again, if we take when x is -5, this is the sort of, considering the graph, we can see it fairly obviously, but we would also perhaps think about it like this so we didn't have to draw the graph every time. So if x is -5, g of x equals 25. When x is 0, g of x equals 0, and when x is 5, g of x equals 25 again. So we can see that our function is going to go from 0 to 25. Now, just to be very careful about this, remember that our values that we put in can equal -5 or +5. So we can get our function to, sorry, I've put x and I shouldn't have put x, should I? We need g of x when we're talking about our range. We're talking about the output values, and g of x represents the outputs. So g of x can actually get right up to being 25. It can be 25 if we put x as 5 or -5, and of course it can equal 0 if we put x as 0. So we do need to be quite careful about our inequality signs, and that is our range. Final function is 1 over x, and it's just between 0 and 3. Now, quite cunningly, we're well, not cunningly at all, we cannot use 0. It must be bigger than 0, but it must be less than or equal to 3. So if h of x is 1 over x, then h of 3 will be a third. So let's consider that first, and we can see on our graph that that is the lowest value we get out of our function. The highest value we can get out of our function is actually infinitely big, isn't it? The closer we get in this direction to 0, the bigger our output's going to be. 1 over a half will give us 2. 1 over a quarter will give us 4. If x is a tenth, we'll have 1 over a tenth, so that h of x will be 10. If x is a hundredth, if x is a thousandth, in fact, we can get x as close as we possibly want to 0, as long as it isn't 0. And then, of course, h of x will just continually get bigger and bigger. So, when we're talking about our range for h of x will be greater than or equal to a third. It will be equal to a third because this is x must be less than or equal to 3. So that would be our range, and h of x is a 1-to-1 function. Okay, that's about enough for now. Just pause or stop, move on to the next one when you're ready. And I hope this has been helpful, and of course if there's any problems, let me know.